Hi, welcome to another video on my Arduino Mega2560. Last time I have been wondering why my pin 13 was not behaving as I expected, and then I am talking about this. If you remember from last time, this was my first attempt to put a frequency on pin 4 and 13, and therefore I use, to accomplish that, I use register 0. Here I use a slightly different way of doing the same, also using register 0. However, the question is, why does pin 13 not behave like pin 4? Well, actually that may be because of this. When you use pulse width modulation, you actually put it on an analog using an analog write, and as you can see, there are a number of pins involved, but not pin 13. So let's take a look at this part of the code. Let's rule out for now this, rule in this, so we have the original way of doing things. Not quite, because I also have to do the eraser. So now I have an eraser for register 0, timer 0, and that is 4 and 13, and here's the prescaler with a frequency of, let me check for security, yes, that is correct, 30 Hertz. So I want to do the same on pin 4 and pin 13, so yeah, it's a bit of a mess here right now. Anyway, for now I am going to copy and paste, and now I have to be careful. Yeah, right, I don't need that for now, because analog out pin, and here analog out pin, that is there, so I need to do an analog out pin here as well. Just a definition, and then we say 13 is 13. With that defined, this will become 13, and then we can take a look at if now 4 and 13 actually give the exact same frequency and pulse width modulation. Well, pulse width modulation you can't verify like that, like with a multimeter, because I don't have an oscilloscope, but with the frequency setting on my multimeter I could. So with this slight introduction, I do hope that it will work. If not, I will have to find again. I will have to search again. So there goes. And that's it. Let's take a look. So, with everything running smoothly at the moment, well, 3 motors, the chain motor, it is time to actually verify if my assumption was correct regarding pin 13, which is right here, with wired here, no, wired here actually, and this wire is also connected. So let's see what the result has been. And this is not exactly what I expected. 9 kilohertz. So that doesn't work. And with pin 4 being right here, no, let's check for security. Pin 4 is right here. Why does that give 10 kilohertz? Maybe because I put it like that in the software, but this is obviously not what I anticipated. This works, this burns brightly, but on a very high frequency. So let me take a look at the code. Actually, that code makes sure that it gives a value from the sensor, from the analog in pin. And the analog in pin is 13. So analog in pin 13 is actually a double I think I made a thinking mistake during the in course of time, because analog in pin is 13 and now I am but the analog in pin is going here to 12. So if I probably have to change that. Would surprise me, by the way, because this, if you look at that, here and here, it is having its effect on the LEDs. So with that in mind, let's check the code again, because how can this function when I do some wrong programming? Well, anything is possible, but I doubt it is like this. So back to the code. Now keep in mind that the input from the change switch is over pin 12, not pin 13. Here it is there's no pin 12, and here is pin 12. Pin mode 12 is defined as input. Here there's no pin 12. So pin 13 is definitely used as an output. And here also digital read is 12. So that and here also input 12 is clearly the input that you can see when you watch the serial monitor. Very long time 0. And then once in a while there's a 1 coming by. So that is clearly 12 and no 13. Now I want an output value from the same thing like here. So this sensor value is from analog in pin, which is what is analog in pin. Let us look again. Is a 0. That is analog in pin. And the analog in pin gets its value from that is actually going to a potmeter. So all my experiments has led to a bit of a mess, but what happens when I, as an experiment, switch off this and switch off 4? How will that be for the frequency? Will 4 leads to a frequency of 30 Hertz. So that if this output pin 4 is here commented out and this works, it should still be 30 Hertz. So with that in mind, I am very curious what the result will be. Very curious. So I am going to compile and upload, and let us check. So when measuring anything with a black probe connected to mass, measuring pin 7 is 30 to 40 Hertz. Pin 6, 40 Hertz. Is that no, pin 3, 30 Hertz. Nice. Next one, pin 5 is 30 Hertz, as should be expected. Then once again here, which is pin 4, far from 30 Hertz. And once again, pin 13 Hertz, and this is 14 to 13 Hertz. So now, while pin 3 was correct, or pin 4 was correct, it's gone now. So this kind of riddles me why things go for the worst. Let me check here as well. It's a very nice 30 Hertz mostly. Here too. So what makes now pin 4 and 13, or more appropriately 13 and 4, go wrong? I'm not quite sure. It may have to do with programming, although that shouldn't be accurate. That shouldn't matter. But I think I will return to the alternate way of programming with the logical AND and logical OR, and then see how that influences anything, if anything at all. So for now, let's go back to the code. So here I have the prescaler for timer 0. So I'm taking this out, and I'm taking this one out, and I'm inclined to say okay, 32 60 Hertz should be perfectly fine. Should be working for both pin 4 and 13. Let me see if I have forgotten anything. This is the eraser. Eraser is alright. Nice for the other things. And to avoid confusion, I actually think I'd better take these out and put them here. So I have here the alternative for timer 0, and this is the other way for timer 0 and 3 and 4. I think this is best. No confusion. Or should be. Yeah, so let's check this out. And have a little look with the meter. And 60 Hertz, it is 60 Hertz, right? Yes. But this is 7 kilohertz, and the other one is way off scale now. Let's see if I measure wrong or right. So this doesn't make sense. Why would this be? Why would both 4 and both 4 and 13 now give different than 13 gave different than 4. 4 was alright. This is not logical in any way. Let's think about it. With the code checked once again, let's take a look at the circuit and see what works or not. This LED was placed here, and this one checks out to be working. The replacement LED has checked out to be working, but isn't working. So if I take a look at the probe, it's a very fine 30 Hz, no problem whatsoever. This LED is working fine with a bright light when the chain is going, measuring a great 30 Hz. This one is obviously working in the same way. Measuring gives a very great 30 Hz. Exactly the same. This LED is working. When I put it on the power controller, it works great. However, it doesn't do anything in the circuit. This motor, not turning now, not working, but it did earlier. And I checked with the power controller, nothing wrong with it. So where does it go wrong? I checked with the frequency. It says 8 kHz, but that's more than fine in this case. So there are a few things that are very, very strange in this setup. And if I knew where to, for instance, why the pins 4 and 13 are acting the way they do. This one used to be 30, isn't. Then this one, 13, once again measuring. Measuring 16. This one measuring 10, so it's not even the same. How come? Good question. This motor is running every time, and when we check for the motors, here's a transistor, here's a transistor, here's a transistor, and here is one. And all the transistors feed a motor. Lesson learned in the past, without a transistor such a motor won't work. But then again, what do I need to have this LED working and this one? Because they should. They should be working with a very fast blinking. Maybe it's so fast that I can't see it. but I'm not convinced of that. Not convinced at all. Let me measure this one. 12, 13 kilohertz. And this is 0 because it's 0. And the LED is connected just fine. Oops. One of the connectors, the chain motor just goes out. There it goes. So, questions all over, and I don't have an answer. And that concludes this video. So, yeah, more questions than answers for now. So, ending this video with more questions and answers. As said, odd frequencies, LEDs not working, a motor not working. Let's check here. Any riddled here. These frequencies work fine. These work fine. This should be, and this was fine. Pin 4, pin 13 is odd. 60 hertz is not shown. It should be shown as 6, but it goes to 16 and 12 and 10. So very yeah, you can call it weird science. I tried to find a solution in defining analog out pin 13, but it had no influence whatsoever. And well, that's it for now. Thank you for watching. If you like my videos and you haven't subscribed to my channel yet, please do so. If you like my videos and would like to support, please visit my website, which is listed under this video and at the start of this video. And on my website you can find more projects and information on how to support. Also find my Instagram with nice pictures. And if you don't want to follow me on or subscribe to my YouTube, you can also follow me on Twitter. And this is certainly to be continued. So, bye bye.